You guys hear me?
Yeah, we can hear you now. Awesome.
A little
All
bit quiet,
right.
but we can.
That is true. All right. It looks like we are live. Thanks everyone for showing up. Today's the Core Dev meeting number 78 on January 10th. The first topic of discussion was the EIP 2387 Muir Glacier updates, just talking about how it went. And I think the cat herders are doing a review of it, if I'm not mistaken, and we'll have Pooja talk about that a little bit if that's happening. But first, I guess let's throw it to whoever added that. So that would be okay. I guess Tim added that, but does anyone want to speak on it?
Yep, I can talk about it.
Great.
So we blocked 9,200,000 for those following home and home. We had Muir Glacier activated, and it actually went off. That while there was quite a bit of drama before in the community about it, technologically speaking, it went off really well. And three of the four clients were perfect, and Nethermind had a quick update that happened afterwards without any negative effect. And that fork included the EIP for pushing back Ice Age, which now block times have reduced to fastest they have been. Since then, it took about a day for the block times to reduce. So we're operating as normal, which is great news.
All right. And then any of the cat herders want to discuss what we're doing about a post mortem, or have we done a post mortem for Istanbul? I thought someone said we were doing one, but I haven't kept up as much as I should.
I'm not aware of the like postmortem of Istanbul, but yes, certainly come across discussion. I'm not sure. Was that you, James, working on it? And yeah, we are willing to help you on that.
Oh, great! Yeah, I am working on a postmortem for Glacier, and so I can.
That's it. Yeah.
And we should also do one for Istanbul. I have some kind of initial um, suggestions or takeaways, but it's not really a finished state yet. So I can say some about that, or we go later and only get back with you on.
Mm-hmm.
Yeah, to sum up, Muir Glacier really did really good. Like it was, the percentage of readiness was more than the Istanbul, so it was over 92% at the time of the fork, and currently it is like 99.5%. So yes, we did really great with the Muir Glacier. To sum up.
All right. Awesome. Any other people have comments on that?
And the main comment from me, I mentioned that on the offer death is that we probably would like in the future to move Dropson block forward in case we realize that Dropson will be happening after mainnet.
Yeah. That's a good call. And so what you're saying is it should be like earlier in general?
Yeah, always the testnet before the mainnet.
I thought that was what we tried. Well, no, we actually didn't really care for this one because it didn't affect the testnet that much, but we probably should do that in the
It
future.
was supposed to hit about the same time, but it's actually going to be hitting next Monday, about a week and a half late.
Hmm.
Yeah, the target was to try to have it be around the same. We thought we rather than give Robson 2 weeks to update their notes, we're like, well, we'll give them the same amount of time, and then the
Mm-hmm.
time happened. It all went back on both.
The expectation was like it would happen under the window of 48 hours for both mainnet and the testnet, but somehow Robston got delayed, and like yes, it is coming up like around Monday this time.
Okay. Well, that's good to know. Um, the next thing is testing updates. Um, Let's see. Do we have Dimitri on? No. Does anyone else have testing updates? Okay. Next, we can go to the eligibility for inclusion EIP review. The first one is going to be 2456, and that's one that Dano added to the discussion. Um, so, yeah, go right ahead, Dano.
So this is a proposal to try and move the fork instead of picking a specific block to try and get some methods where we can go on a time. And getting a time-based fork is a tricky issue. There's plenty of ways to introduce new attack vectors and ways to um, basically make things more complicated than they would ordinarily just by saying, well, we'll fork, next Wednesday at noon. Um, so my motivation for this is these past two fork blocks because of the Ropsten and mainnet forks that were proof of work forks. They were all off by at least 3 days. And as I mentioned earlier in the call, Ropsten at its current rate is going to fork probably early next Monday morning, which is about a week after our intended fork time. And there were times where it was forecast at the block rate of the current to fork 2 weeks afterwards, and that's just that level of unpredictability is just incredibly bad for our downstream partners who have to maintain nodes and run exchanges. So the first proposal I put together, I'm open to other proposals. I just want to get some sort of a mechanism that is predictable into a much smaller window. So one of the problems with the with forking on a date is we have to deal with honors, um, and there's also the issue of reorgs. Reorgs, I think, is initially the most obvious issue, although honors is also a very subtle issue. If we fork on a specific time, what if there's a reorg that includes that block number? That also gives the miners some opportunity to play games with the numbers to try and force forward to the fork. Although Geth parity Basie that I know of only accept blocks 15 seconds in the future. I don't know about Trinity, Aleph, and Nethermind. I don't know what their rules are. But even then, you can have all sorts of difficulty if you're trying to fork at a specific block that's not random. It could be random. So the first thing that I proposed is that the transitions only, the network upgrades only transition at block numbers that are round by 1,000. And the second thing is I proposed a two-phase commit, that we do the transition at the second opportunity where the block number that is round 1,000 is after the fork time. So that gives us a window, that gives us a trigger event about 1,000 to almost 2,000 blocks in the past to say, hey, we're going to be upgrading at this block about, on average, 1,500 blocks in the future. And there's some calculations that I did in there to say that this would happen anywhere between 2 and 20 hours after the fork time, which is a lot from 2 to 20 hours from the initial time proposed, which is a lot narrower a window, a lot more manageable. In theory, you could have somebody working full time during that window rather than putting someone on all the time for 20 hours. On Ethereum Magicians, Peter was concerned about the Omers, if there was additional rules that might change the header validation, how a malicious miner might be able to litter the Omers with transition eligible blocks. Luckily, it looks like the two-phase commit on round numbers is going to limit that window to about 3 blocks before the second transition that they could fill it up. And even then, there's economic limitations on how effective that can be. There's only so many Omer blocks you can include to get credit for. And that's no different from just going crazy at a particular block and doing a very hairy transition at that point. Yes, Peter?
Yeah, I just wanted to ask that, say that my concerns aren't necessarily malicious miners doing weird things. Rather, it's just the complexity of consensus rules. That in theory, so I'm not sure how the rules are currently laid out, but in theory, it could happen that so one of the blocks already fork. I mean, already go into the next fork, but the uncle block remains in the previous one, or a weird scenario where the uncle is already forked, but the block itself is not yet forked. So since the timestamps aren't really, the uncle and the block timestamps, as far as I know, aren't tied together, you can have these really weird scenarios. And I think that mostly the problem is, or the complexity is, that we should really pay attention to and define how uncle timestamps versus block timestamps behave, so that we don't accidentally get into a situation where one client rejects something and the other client doesn't. So that's mostly my concern.
Yeah, bugs are actually more difficult to untangle than a malicious attack because it's pretty usually obvious what they're doing there.
Same issue with this as Peter brought up, I think. And I wrote it in the fellowship, and I have since edited it because I realized that it was based on a misconception. So if I understand it correctly now, your proposal still activates on block numbers. So an OMER would never ever activate before the block. I mean, if it activates on block N, all the OMERs will be older than N, and none of them will be activated. And the whole timestamp is just opens up the window saying from in between 1,000 blocks from now until 2,000 blocks, the fork block will happen, right? So
correct.
So I think it's elegant that way.
It's
because
like we
with
have
this
an awkward
scheme, we can like.
Go ahead. Go ahead, Martin. Or you use his microphone. I think Martin's microphone's down.
Can you hear me now?
Yes.
Oh, okay. Yeah. So I was saying, after the fact, once the fork has happened, we don't even have to. We can pretend that we never had the timestamp rule there at all. We can just set the fork number was blah and hard code it there.
Right, we can, because we've never had a 1,000 block rewind. So that was something I went back and forth on the decision, whether after the fact we go back and make the number canonical, or whether we stick with the date defining the number. That was something I wasn't too sure on.
Well, but honestly, is there a reason why we would remove the date in that case?
Yeah, because it's easier right now. It's easier to, when we do syncing, we can do checks for specific blocks if the peer has them or not, and if if we want to sync to after that block and check that it's on the right side of the fork and stuff.
So I'm remembering the reason why I went back to having the dates be the permanent number, and that has to do with the 21-24 interactions. Since we don't know the future block, we would be advertising a future time. And unless we then update our record at the block when we think it happens, if we stick with that number, meaning when the fork block is, we don't have to change our hash nearly as often. Otherwise, there's a small window where you might have a difficult time peering based on that identifier. And I did mention in the block that clients might want to include both the fork number and the fork time. And so, like during a fast sync, you could use the block number as an aid to make sure that you're doing it correctly. But in all the synchronization methods right now, everyone's getting all the headers anyway, so you'll have time to validate. And since you're only checking every 1,000th header, it shouldn't be too much of a validation burden on fast syncs.
Ooh, but you do have a point that if we tie forking to timestamps, then the fork ID gets messed up, because the fork ID is designed to operate on blocks only. So that needs to be redesigned too.
Yeah, I think we could just put in the Unix seconds past epoch, because until we hit block number 100 billion or something, I think we'll be fine. Or maybe it's just 1 billion.
Yeah, I mean, probably it's not too hard to fix, but it's something that needs to be addressed.
Any other comments?
Just a question of why is it that Ethereum it is so irregular, or is as if I look on Etherscan, the average block times end up being pretty consistent. but then off so long, and what is sort of underlying that offness, and is it would also be getting a more consistent block time be something that would solve
So
or help
what's
address.
hitting us on Ropsten is hash rate is a much more highly variable than it is on mainnet. There's no economic incentive to keep all your hashes pointing to make money. As we experienced with Istanbul, somebody pointed a lot of hashes at early because I guess they were testing a new rack or something, and they doubled or 10x the hash rate, and so that brought it forward 3 days sooner than we thought it was going to happen. We wanted it on a Wednesday, and it still happened on a weekend. For mainnet, what hit us with Istanbul was we were not sure what the impact of the ice age was going to be. We didn't know if it was going to be a half a second impact, a 2-second impact, a 10-second impact. I think our estimates for getting Muir Glacier on the 6th was based on a 20-second block time, and it wound up being 17, which pulled it into the day after New Year's. So it's the things that we can't predict is why getting a date, there's an SI definition for second, and we're going to follow that. But there's no SI definition for how fast you can hash, and that's the unpredictable part there.
So for Robston, this would be that the unpredictable hash rate will be a problem moving forward. And then for mainnet, in previously has it been that far off when things are acting normally? Like assuming the ice age gets fixed, because that's I'm working on that after I get this postmortem done.
I'd have to look at those dates. That would be worth putting in the EIP.
I think in general, previously we managed to hit the fork more or less accurately. But for example, I think Petersburg hit at somewhere around midnight UTC. So again, I'm not sure whether that was intended or not. I assume it wasn't really intended. So for example, what a time-based fork would also allow is to, essentially, it would allow you to delimit the fork within 2 hours. So you could say that this fork is going to happen between 6 p.m. and 8 p.m. UTC, and then everybody knows specifically that you have to be online at that point in time. Otherwise, if you schedule a fork 1 month or 2 months in advance, even if you're pretty accurate, you can't really be hour accurate. So yeah, you can most probably get the correct day, or maybe give or take 1 day, but definitely not give or take 1 hours.
And I think one thing that's nice about this proposal is the fact that there's like this 1,000 to 2,000 block delay, which is like, I don't know, a couple hours. So you can imagine a case where like you do set up alerts for that time, and then it gives you like 1,000 block warning to, monitor the fork. So that, and also just like within the community, it gives an opportunity to message that like, hey, this thing is happening in a couple hours. The only potential drawback I see is whether or not having this window would mean that like exchanges and whatnot would pause deposits and withdrawals for a longer period that they do now. So right now, I think they only do it for a couple hours. But if this is like 1,000 blocks, I'm not sure if that's longer or shorter. But on net, it's probably good to give this like 2-step warning that the upgrade is happening.
I'm not sure. So if your node is the one warning you that there's an update coming in half an hour, I'm not sure you have time to react meaningfully. So if you haven't scheduled it in advance.
Sure, yeah. You need to schedule in advance, and I doubt the node would like inform you of that. But like 1,000 times 15 seconds is still a couple hours, right? So
there's a chart in the EIP for 13-second block times. It could happen as soon as 3.5
like
hours,
4
and
hours.
as late
Yeah.
as 7:15 after. And there's about a 4-hour window for 15-second blocks. If the ice age has gone bad and we have 30-second blocks, there's like an 8-hour window with an 8-hour warning. And the thing is, you'll pretty much know once the transition triggers. You'll have 8-hour notice basically of when it's going to happen within an hour, I would say. Or a 3-hour notice if we're at 13-second blocks. So you'll be able to nail it down pretty tightly as to when it's going to fork.
I'm liking how this is progressing, for sure. I think a time-based fork would be better if we can pull it off. Anybody else have comments? Martin, your mic's being a little crackly. I didn't know if
Yeah,
you were trying to
I'm
talk
no
or if it was
comment.
just your mic. Oh, okay, perfect. Um, okay, we can go to the next part of the agenda. That's going to be EIP 1962, eligible for inclusion, or the eligibility for inclusion of EIP 1962, and that's going to be Alex, and I think Louise is here for that too, right?
No, I just happened to come here to listen to the what's going on around.
Oh, perfect. Okay, Alex, you can take it away.
Yeah, so as I written briefly at GitHub Assure, right now both C++ implementation and Rust implementation are both complete, both feature-wise and from testing perspective. Their performance is also within some plus minus 10% deviation. So I use the Rust as a kind of metering source for all the gas estimates. So in principle, right now, what's left is basically how I should integrate it into few existing clients. I'm only familiar with parity and gas. And there are a few options whether to use kind of the single implementation or use two independent implementations in two independent clients, for example. And with all of this, because, well, for parities, the Rust library is easy to include and compile. For gas, it's not that easy to compile C++ source and or the Rust library in any form. So like it would require some kind of additions into the existing continuous integration pipelines. So all those advices would be welcome or comments on this part. Also to simplify alternative implementations, because I know that there is one happening right now in Go, which is still non-complete as far as I know. Maybe it would be possible kind of to put a performance margin, like use the current numbers for gas metering, which are acceptable for Rust and C++, and just say, well, alternative implementation in Go, for example, would not be more than, for example, twice slower than those two existing ones. And so I can incorporate all those changes.
Yeah, just from the Go Ethereum team's perspective, so for us, the C++ approach is definitely doable. So we can easily integrate C++ or C code into Go. However, we cannot integrate Rust code. So the only thing we could do with Rust is to have a completely separate Rust compilation step that builds a shared library or a static library, and then somehow link that to Geth. But that completely and utterly blows up the entire build process. And then instead of using Go as a build tool, we would need to have make files and custom steps, and that's definitely not something we want to do. So technically it is doable, but practically it just nukes the entire project simplicity. So from my perspective, we definitely would like the C++ approach.
Yeah, so the C++ implementation is written in a quite modern dialect of C++. And well, not even the library itself. It also relies on the dependency, which does all the arithmetics. So the arithmetics implementation is not done by me in C++ code. I've taken the existing one, but it still gives me the same results as in a Rust, where I have written it all by myself. And those two require C++ 17. I don't know what containers you use in your building pipeline, and just depending on what Linux edition and distributive you use, you may have or may not have the modern enough compiler. This is my only concern for C++ side. Otherwise, if you say that you can easily build C++ in Go, where I had some problems as far as I tried the last time, then sure, it's as good for me as any other.
So C compiler version wise, essentially Go is just calling GCC. So as long as you have a version of GCC installed, it shouldn't matter what kind of C++ features it uses. If you had some other issues, then maybe just mention them somewhere, and then we can take a look.
No, it just requires the C++ 17 standard. Just basically a few features which were even supported in previous versions, but officially are only C++ 17. Otherwise, it's standard.
Yeah, so it might not be trivial, but still, linking against Rust would be really nasty. Martin, are you trying to say something?
Yes, sorry for making noise. So what I read on your comment here that that move to 10 separate operations that may map to precompile addresses. And I looked at the EAP, and I've seen no such changes in the EAP. So I'm kind of wondering where these changes are taking place and where we can follow the progress.
Well, there is a kind of reference Rust, a reference GitHub with also Rust code and also a few documents which describe the binary interface and operations, which are now 10 separate of them. I just didn't make I just didn't make another pull request to the EIP to update it to the current state, but I still maintain the list and kind of also description of binary interfaces now with 10 separate kind of operations. I mean, Dano asked for this a few times, so I just implemented this change.
Okay, yeah, but it would be good if you could post somewhere what is the canonical source of truth and progress for 1962, because it's to me it feels kind of spread out.
Okay, I will make a post to magicians in a corresponding thread. Yeah, so well, basically there are kind of two implementation-wise and integration-wise questions. Like what, because most likely I will do the integration to the parity myself, is to have what precompile address range I should use for which should be 10 addresses, and basically just what is the number for this kind of performance margin for alternative implementations, if there will be some in the future.
Anybody else have comments?
Did I hear you say that you had made a pull request and you were waiting on that to go through, or you were waiting? I just want to make sure I got it right. Or the EIP, like updating an EIP.
Sorry, I think I just didn't get your question. Can you repeat once again?
For the actual EIP in the repository, or did you say you made a pull request and were waiting for it to be merged, or that you are waiting to make?
Oh, well, I mean, I have the draft for the parity client, which can be which is completely draft, but basically it integrates calling the Rust implementation and gas metering routines from the parity client. But to integrate it completely, I would also need to change few config files, I think, which will require me to have to know the addresses for all these 10 precompiled functions, which people wanted me to make, which should be mapped to 10 independent precompiled addresses. And just to finish this integration, I would need to know these addresses.
Yeah, is that something that we have a process for deciding? Just everybody on the call? Like when we assign precompiles, which ones do we just decide in call?
Typically, that's what's been done. And they've always been packed tightly, so there's been no open spaces. That's something we might want to reconsider or not. So
Yeah, just we'll have to think of the pros and cons. For the moment, we can just continue to go with that, though, if we want to just give Alex an answer. How soon do you need that answer, Alex, or does it really matter?
I mean, if someone would want to integrate it into parity, for example, themselves, I think I'll say in Go, when people will need to integrate it, they will need to know this information. I can just leave placeholders for now, which is not
Okay.
that important, I think. So the second question is kind of performance margin for future if alternative implementations arise with a little bit different performance. So right now, the difference between C++ and Rust is 10% and kind of plus and minus in different parts, just more like a deviation. Uh, but for the future, if let's say there will be some other implementation not that performant, but still alternative and matches to existing ones completely, and someone would want to use this implementation, for example, in gas, then we can just kind of give uh, the performance margin. So I will just blindly multiply all the gas prices by 2.
Yeah, the problem with it's not just the gas prices generally, but so if the margin is 10%, then nobody really cares. But once you start entering into 2x, 3x territory, the problem is that those start to look like denial of service opportunities. So, for example, either you would double the gas price, in which case the implementations, I mean, in which case people would be just charged more and blocks won't be as useful. Or if you keep the gas price at some meaningful levels, then a slower implementation could just be too slow for the network. So I
Yeah,
think 2x is probably something that is still okay and doable, but above that, you will start to get problems.
yeah. For this, I would need an advice. I can do the, I can just do the comparison with the current BN curve. Right now, for most of the operations, it's cheaper. I just didn't try with the pairing operation. So even for example, 1.5 coefficient is still a good margin anyway, and just as a security feature too, even if uh, later some required modifications or extensions will require, will decrease the speed of one of the existing implementations. But it still should be, first of all, faster than the existing precompiled for BN curve with the current pricing after the first Istanbul fork. And second, it will give access to wide set of the curves which are not accessible right now, which is still beneficial. I mean, it's beneficial from both sides. So it will not make precompile completely useless, but the coefficient, whether it's 1.5, for example, or 2, I also wouldn't want to go above 2. Would be kind of a way to allow people to make alternative ones in other languages, which will kind of not give this exact performance. I can also put a placeholder like 1.5, and this still most likely would be fine. We can decide on the exact number later on.
Yeah, so generally the way we decide on these gas prices, just if we have multiple implementations, just try to run benchmarks on on different machines with the different implementations, gather all the numbers, and then just try to compare it to the existing opcodes, and then just boom, give a number and maybe multiply it by a bit just to be on the safe side. So I think in general, if we have some benchmarks or we have some code that we can benchmark, then we can fairly quickly dream some numbers up. I think Martin also had some benchmark suite that spits out all kinds of nice stats.
Yeah, but the whole doing that requires us to be fairly certain that we know the worst cases, which is not trivial.
Yes.
Well, this was largely part of my work because I also did the gas schedule. I mean, I have all the formulas for gas scheduling depending on the input parameters, and to measure those, I for parameters which are in a narrow limit, I use it worst case scenarios. Like for example, if you multiply the elliptic curve point by a number which is in certain range of the bit widths, worst case is just having all the ones, like all the bits set. So you have the maximum number of additions and multiplications, basically doublings. All those were used in a gas estimate. So those numbers are worst case right now. I can just give a margin on top of this.
Right. But then you kind of run into this other problem because now you have gas scheduling, which alters the model of the worst cases. I mean, yeah. So then you get new worst cases based on the gas schedules, since that kind of rebalances everything.
I mean, what do you call new worst cases based on the gas modeling?
I mean, not worst cases as in the ones taking the most time, but the worst cases as in taking the most time per gas.
Well, I mean, okay, like there is a set of parameters for every operation which is happening right now. For example, addition of two elliptic curve points is basically a lookup table. It only depends on what is your field size. And for this, basically, I just give the lookup table because those numbers do not depend on anything else but the number of by kind of the bit widths of the modules. For multiplication, there is bit width of the scalar, but by which you multiply, and those also are kind of split into windows each or categories, which each of those is 64 bits wide. And in each of the categories, I use the worst case to give the gas scheduling. So from this part, it's kind of well, it's the safest way because I should not introduce the naive service. It's maybe not the most optimal way, but I mean, right now it's already safe if the C++ or Rust implementation is used. So it's only a matter of whether we should put kind of additional safety on top of this, which will kind of relax the restrictions for alternative implementations in terms of speed.
Yeah, okay, but just to give some context then. So previously what we've done kind of is compare the relative gas per second or second per gas against, for example, easy recover.
Oh, well, I mean, I used kind of, as far as I understood, the standard measure of 15 million gas per second in my gas scheduling.
Yeah, but when you do that, you become heavily tied to the actual processor and machine hardware you're using. So what you can do is you can, on that machine, you calculate, so where is easy recover and perhaps a couple of the other precompiles, and then you reference against those. So you get a similar gas per second as, for example, easy recover.
Well, so right now this number, which is 15 million gas per second or just 15 gas per microsecond, is a global constant which I can change. And if this is a standard measure across all the machines in which you use the benchmarks, I will just, and if you can point me to some benchmark which will allow me to check what is this number on my machine, I can just adjust it. So it will be directly apples to apples.
Yeah.
So is there existing is there existing code to do something like this, or should I just write one myself?
Yeah, I can send you the example repo, the repo containing the examples and the benchmarks that I've done previously for other precompiles.
Okay, yeah, I will. Yeah, then I will just measure this constant and make adjustments.
Okay, are there any other comments or questions? Okay, that's great progress, Alex. Thanks for the update. The next EFI EIP is EIP 2348, validated EVM contracts. So that's going to be Dano.
Yeah, this one will be shorter. I just want to point out that in the Ethereum Magicians Forum, I gave responses to two of the concerns. The first one was about validating in transactions, and my principal argument was that the contract can't be too long because of the gas limits. It's either going to be 2.5 if it's nothing but zeros, 2.5 megabytes, or something between half and a full megabyte if it is not full of zeros. So I put some numbers in there. I don't know if those will address Martin and Peter's concern about the attack. So this is a request for comment in that thread. And I also, the second concern was about why headers and why not some other mechanism to identify contracts that are subject to the validation rules. The strongest argument actually came from some of the work that Way's been doing on his ungas, where he's proposing to change the call, delegate call, to take 6 instead of 7 or 5 instead of 6 arguments off the stack. And if you were to put that EVM into an unvalidated EVM, things would break unexpectedly. Whereas if you had the version header, they would break quicker and more predictably. So I'm not ready to have it voted next week, so it's at least a month away. So I just wanted to take the time to solicit responses in the Ethereum Magicians thread.
Okay, thanks. Anybody have a question or comment? Okay. Next, we have the EIPIP meeting. Oh, go
I
ahead.
was trying to find my mute button. Yeah, I'm Dan. I'm of course generally in favor of something like this. I've had time to look over the thread, but not to really study this and the related proposals. So over the next month, we should try and find some time to go over it.
I think I'll be more prepared
Anybody
in
else?
2 weeks. I just barely got the responses on there yesterday, and I think people should have a week to be able to respond to it before we discuss it on the call. So that's why I'm not prepared today.
Cool. Anybody else? Okay. The EIPIP Ethereum Improvement Proposal meeting, also known as the EIP Improvement Processes meeting, is going to start happening next week. I need to still schedule the day. I don't know what day is best. I'm going to guess Wednesday. That feels right. And that's going to be organized over Telegram, but I might do a chat bridge to Getter if that'll help some people. Reach out to me, preferably on Telegram or at hudson@ethereum.org if you want to be included in those meetings. The purpose of those meetings is to look over and streamline some of the EIP processes and also create guidelines and actionable ways to attract EIP editors so that we can have a cleaner EIP process in the future. We don't have like a timeline for this. It's still pretty early. It's just going to be some discussions and then we'll start structuring it a little bit better. And I think that's it for that item, unless there's any questions. All right, review the previous decisions made and action items from call 77. The first two are about Muir Glacier. ECH released the blog post on Muir Glacier. They did that. Hudson to connect the clients to get the latest versions of Muir Glacier, ECH, and I did that. Action item 77.3, create an EIP IP Telegram channel. Yes, I did that. And again, you can email me at hudson@ethereum.org or chat with me on Telegram to get added to that. Action item 77.4 is for someone to contact Eric and add the block rewards are unchanged line to the EIP. I don't know if that ever happened.
I did that.
Okay, great. Then that clears up all the action items. And I think that's the last thing. Does anyone else have anything they want to add to the meeting?
Yes, I do. I
Yes.
just want to bring to the attention of this quorum. There was we had a discussion between Starkware and Geth about the maximum transaction size of in the mempool to get accepted into the mempool. We this has been even in being resolved with the Geth team. They had a limitation there, and I just want to bring it to the attention of the other client that this limitation or other limitation could be problematic for many layer 2 solution. Hello? Can you hear me? Yeah.
Yeah, we could hear you.
Okay.
And you said this was the size of the mempool and
No,
clients, like by default?
No. So, I mean, I can let Martin and this is getting solved on this. We already had a diary discussion for a few months, and this is getting solved. I just want to bring it to the rest of the attention that this sort of limitation could be a problem for L2 solution in the future.
So essentially, up until today, actually, Geth was refusing to forward or propagate transactions that are larger than, I think, 32 kilobytes. That 32 kilobyte was more or less picked because the contract deployment limit is 24 kilobytes, and then 32 seemed like a nice limit. And of course, if you want to create a transaction which has a ton of data but doesn't really deploy anything, then it could happen that you might want to create a larger transaction. And then Starkware made a PR that actually extended Geth's transaction pool so that we can accept larger transactions. It's mostly the work was because we wanted to make sure that no denial of service can occur due to transactions. So I guess the important memo here is that Geth, probably from the next release, Geth will also allow propagating larger transactions. So people might be able to use transactions that are not only limited at 32 kilobytes, but actually at 128.
While we're on the subject, Peter, do you want to mention anything about the proposal for fetching transactions?
Yes, actually, I wanted to do that. Just figured I'll wait until the end, but I guess now is as good as a time as any. So currently, the way nodes propagate transactions in the network is horrible. Actually, Geth relays every single transaction to every single peer it has. In theory, it would be enough to relate to a logarithmic number of peers. The problem is that if you have some weird connection, then it can happen that you miss out some transactions. And the Ethereum protocol currently does not, Ethereum networking protocol currently does not have a means to request transactions. If you missed something, you cannot ask your peers for it. You just have to wait until they deliver it. And essentially, we already have a PR that would, again, bump the Ethereum protocol to ETH65. And we propose adding two message types. Essentially, similarly to how for block propagation, we have a message to propagate a block, and we also have a message to just announce a block and request a block. The same way we would extend it for transactions, so that beside the current message that just propagates a transaction, we would also support announcing a transaction, essentially just the hash, or at least that's the plan currently. And then the remote side could request it if it doesn't have it yet. And we're kind of hopeful that this will help drastically reduce the network bandwidth that the entire Ethereum network consumes. Because then...
Sorry.
Sorry?
To finish, sorry.
Yeah, so essentially that would be the plan, and we'll probably write up an EIP maybe for next all core dev calls. So it would be kind of a small addition to the network, just to add this support announcing a transaction and request it if you don't have it yet.
Yeah, so
It
the
sounds
question
to
here,
me.
because
Go ahead.
yeah, sorry. When we connect networks, when we connect nodes to each other, I think in the moment Get is sending all the transactions it knows about on connection. Is it possible to change it so it only sends hashes?
Yeah, exactly. That would be the other thing. So if we support announcing transactions, then on connection it's enough to announce them. You don't have to actually propagate them.
Yeah, that would be perfect. I think this is the
It,
80 or 90% of the traffic at the moment.
Yeah,
it
exactly.
sounds to me very similar to what Bitcoin is doing with, I don't remember if it's either fiber or compact blocks. There could be something to be taken directly from them.
Well, this is really kind of trivial, so it's just the same. So currently, the Ethereum protocol, you can request blocks by hash, you can request receipts, you can request everything by hash except transactions. So it would be extending that, and the same way that you can announce blocks, it would. So I don't. I mean, if you have a link to somebody else's work, we can definitely take a look. But this is really something super trivial.
Yeah, it seems
But
simple
I
and
think
but what you're referring to is doing the same thing for the actual blocks. So you propagate blocks and you only include the hashes of the transactions, but not actually the transactions. And that
yes, it is
is
what
not the same. It is kind of a follow-up thing that we could do, but right now that's not what we're going to propose.
Yeah, so that's definitely also something that we've been thinking about. But in reality, we wanted to, so sorting the transaction propagation problem out is fairly trivial. So just a tiny addition, we can get a new protocol version released and see that it actually works. And then we can look at the whole block propagation, whether that's an issue or not. Generally, since we're only propagating blocks to logarithmic number of peers, it's not really an issue in my opinion. I mean, we can definitely make it more optimal, but it's not. It doesn't really cause issues at the moment. Whereas transaction propagation is something that is annoying.
On that specific, I completely agree about the block propagation itself. I mean, if we could reduce also the propagation, then time, which is roughly today 200 milliseconds, if I'm correct, it would be something that would be compared to the mining time of on Ethereum block, it's somewhat still significant. I mean, not as of now, of course. I'm just thinking in the future that could be a nice improvement.
Yeah, of course. No, I completely agree. Just I don't really see a reason to try to do both things at the same time. So I definitely think that we probably
Agreed.
should experiment with that and should do it eventually. Just take it one step at a time.
100% agree. Thanks.
I remember Piper's team was working on an EIP sort of around the same thing. Have you guys connected with them about that?
So I think we discussed this with them back at DevCon. So I think they're in agreement. We haven't talked recently about it.
I'll ping him about it. We've talked about it as far as ETH1X stuff has come up, or things that they need from their client. I'm not on their team, so I don't know. I don't want to misrepresent what they're talking about, but I just remembered that conversation.
Okay. Is there any other things anyone wants to say, announcements, or missed topics?
I have an observation of, and this isn't anything to do with, this doesn't say anything about your EIP or your process, Alex, but I think is a comment on the process in general, and possibly one also focused on improving, which is, if I think back to Blake 2B, and I think back to 1559, and I think back to others, a single source of truth, or keeping up to date where that is in use to be a difficult thing to keep track of. I just want to say that out loud as an observation.
Yeah, I just don't know if I can just make another pull request to update the text of the existing EIP in the corresponding repository. I just don't know what was the previous standard process. I can post it in both places or just continue updating the EIP GitHub, which is like whatever we decide now. I will just do this way.
Yeah, I would say the EIP GitHub, in combination with the Ethereum Magicians thread, if you have one already, that should cover it, in my opinion. And that's kind of what we're leaning toward, or I feel like we're heading that direction standards wise. It was kind of vague before. Um, what do you think, James?
But I'm noticing that there's and this is more of a process thing and less not on your actual EIP, Alex, and you're doing great on that. But um, there seems to be a lot of tension between keeping those things in line. Whether we keep the amount of effort required to keep going, is it worth it, or try it in a way that has less diversions happening or tension in the process.
Yeah, that would be nice to have, and that could be part of the EIP-IP process. Peter, can you post a link to your PR in the All Core Devs Getter?
It's Gary's PR. Well, I mean, I can definitely post a link. I'm not sure how useful it will be to you guys, but sure.
Oh, Trent was just asking for it.
Oh, yes, of course. But yeah, never mind. I'll just post it. But it's not a PR to the EIP. So
Oh, yeah, I see what you're saying.
we just have a code itself, the Go code.
Yeah, the EIP is.
What was that, Trent? You cut out.
Sorry, a link to the EIP would be perfect.
But we don't have an EIP.
Oh, sorry. Thought that's what you said.
No, what I was saying is that we just have a pull request with the Go code itself, but we'll try to get an EIP up for next Codec call.
I have a general question about networking issues. Are they at this point standardized or discussed as part of the Ethereum, like the protocol itself, or not?
What was the question?
My question is if like those networking messages and standard, are they discussed today as part of the protocol itself? I feel like my impression from the outside that they are decided ad hoc by each client. Am I correct or wrong?
I don't think that's correct. So the networking protocol was pretty much standardized even before Frontier, and then we used the usual EIP process to make changes to it. So the only thing that's not standardized is, for example, LES is, since it's only supported by Geth, it was kind of never modified through the all core dev calls because nobody else had it. So there was not really a point to have to introduce all that bureaucracy here. But with regard to the ETH protocol or the dev peer-to-peer or discovery, all of them were pretty much made here. Again, something that was not designed through the all core dev calls was the discovery v5 plus the ENR stuff. But that again usually was because nobody else cared about them. So people just assumed that whatever the dev peer-to-peer authors come up with is fine. But again, Discovery v5 was something that's completely independent and completely new. And after the whole initial specs were done, even before we started implementing it, I think Nethermind already jumped on it. So we had a few other teams collaborating. So it wasn't really collaborated through the all core dev calls, but it was a collaborative thing.
There are multiple things on networking that would actually benefit from being standardized. There is one particular example that I can give from Nethermind. When we were sending requests for the nodes in the fast sync mode, the requests are handled both by Parity and Geth, and the way we were optimizing it. We create the request batches first, and then we decide whether to send it to parity or get. And the limits for the sizes of the requests in parity are at around 1024, and in get, and they are, I think, get handles 192 at most, and requests up to 256. And the thing is, if parity doesn't want to respond to a big request, it actually just sends you as much as it wants to send you back, and you can handle the part and then re-request the rest. But get actually disconnects you as a punishment for requesting too much, which means that we cannot ever use the fact that parity can give us more data, because if we send it without knowing exactly which node we will be assigning it to, then we might be disconnected by all the guest nodes. So these are all these like small things that are not really specified. And if 63, like there is no definition that we should get disconnected. There are some specific behaviors on like when the null headers are sent by get, for example, which was not following the protocol and not specified anywhere. And they're above the bugs reported in the past in parity and in Nethermind when this special condition was found. So any further specification, like very detailed specification of those network protocols to improve it for the future. I think for us historically, this was like the one additional thing would be great, actually to introduce some more meaningful messages on disconnection, like so we can all between the nodes send each other the information why we are disconnecting. Now, like the debugging the opportunity, the situations when the other nodes are disconnecting is really hard. So you very often have to run two debuggers at once, like get third-party code, and at the same time Netherminds to check what exactly was the series of events that led to the node being disconnected, as a like for whatever reason, either it was sending too many messages or something was malformated. That is extremely time consuming. So any more detailed specification would be great work from all of us to improve it, also for any new nodes being built by any new teams.
Just to react to one of them. So you mentioned that get disconnects if you request more data than some limit, and that seems, so that's definitely not something we want to do. So we simply, if you request too much data, then we stop. I mean, we have limits, and for example, if you request 1,000 state entries, then you will get 370 something back, and that's it. And you can request
No,
more.
no, I mean, obviously, if, when I'm reading get code, then I'm more likely to make mistakes when analyzing it.
No,
But there is quite clear code that I found that actually takes the limit, and if the request is over the limit, it disconnects the request, and that's what you see also happening in the actual behavior. I'm talking about nodes, not data, not about blocks or headers.
Yeah, but that should, you probably want to open an issue, because that's definitely not the behavior we intend. So we never intend to disconnect just because we requested more data. So it should be a clear protocol violation. So we only disconnect if you send something that's definitely junk. That cannot be interpreted. So if we do disconnect in some other case, then that's a bug, and you should probably open an issue.
Okay, yeah. I mean, because the code looks like really that was intended, so maybe we should treat it as a bug and raise an issue. But also like specifying it in the future, like what should be the behavior, like if the requests are in different formats, then that would be helpful.
Yeah, I guess here the thing with the fast sync and ETH63 is that when we implemented this whole protocol, essentially Geth was the single client which had this thing. So there was the ETH63 was kind of just spec'd as, hey, kind of these are the messages, but there was not even CPP Ethereum implemented it. This was before Frontier.
I think this is like a common pattern when we hear what we are saying here, that like fast sync was the get only, less the light client was the get only, Discovery 5 was the get only. I think the reason they're remaining for so long, get only, is because the spec would have to be like more detailed, and it's very natural. And we're doing the same whenever we're doing something that only we do at the moment. Then obviously the spec is less detailed. So we should try to resurface all those changes and spec it as soon as possible, and involve more of the core devs to be aware of any experimentations on the client, so we may kind of build some better communication here, and it will help for future.
Yeah, I completely agree, and that's pretty much the reason why instead of why we came with this whole fork idea and we wanted to spec it out as an EIP, and when that's specifically the reason why we brought it up today too, that hey, we have this whole transaction propagation issue and let's spec it out properly.
Yeah, definitely helps. Definitely helps. So it's already a step towards the right direction, and we can only improve here more and more.
Can I just jump on this discussion further? I feel like the core dev also didn't discuss like this post-mortem on the attack the network faced just before New Year's Eve, which sounds a bit like what we've been discussing on networking issues and the way we handle blocks.
Was there an attack?
Yeah, on parity.
No. Oh yeah.
No, it actually affected both Nethermind and Party, and it's almost like there is a second forum of like maybe 20 people discussing both the Parity Open Ethereum, and I was there as well, and we discussed it there quite thoroughly. And because it didn't affect gas, we were not raising it here. So the general thing was that there was the incorrect block being sent, and then Parity was adding it to the cache of the incorrect blocks as the hash of the block of the header. But because the body of the block was modified, but the hash was all fine, so the block was validated, then it was blowing up the processing, and then it was added to the hash as the invalid block, but there were perfectly valid blocks on the network with the same hash. So different hashing mechanisms had to be introduced. And while the same thing affected Nethermind, in our case, it was slightly different thing. So we missed the validation on some of the incoming new blocks, and we've added that, and it solves it as well. And the Parity already has a fix where that cache actually hashes the raw content of the block body and stores it separately. So it says the block is only discarded immediately as invalid if the hash of the content is exactly the same and not the advertised hash.
But this kind of seems a bit weird that you retrieve a block from the network and you don't actually match the contents to the header. So this seems like
So like how it was done on Parity. Oh, actually, we in the discussion we were saying that guest nodes are actually sending that every now and again. Guests are propagating the invalid combinations of headers and bodies. So also, like for example, I'm receiving a lot of invalid nodes from the get node data from Geth. Sometimes the hash doesn't match the content. So whether these are specifically designed attacking Geth nodes or just some bugs, it's hard to say.
But that seems really weird because we don't. So with fast sync, we do run benchmarks and we don't see bad blocks and we never see invalid hashes either. So
sure. So like I definitely should start raising more issues because at the moment we have code that says like only when you send to us something like 10 bad things in a second, then only then we disconnect it. But literally we have to be very very like soft on behavior of other nodes. So it might be that we should start like communicate more on those network issues and then raise it more, and then we'll just remove all of those problems.
So Geth, our monitoring Geth node is still picking up these bad blocks and storing them in the bad block cache. So Geth, like Parity, flags a particular hash as bad, but the difference is that we don't actually use that as a blacklist in the future. We do maintain it, so if we want to analyze it from the outside, we can retrieve the bad blocks, but we don't blacklist based on it. So therefore, later on, once we get the correct body content for that header, we successfully import it.
Do you blacklist before propagation? Because like blacklisting helps to prevent those bad blocks to be propagated. No. So, oh, okay. So we do blacklist them and we never propagate them, but the blacklisting works as long as you do it at the right stage. So Parity was just blacklisting a bit too early. We only blacklist after the full processing if everything matches.
Yeah, so that sounds correct. I mean, that sounds like we shouldn't pass on blocks unless we have matched up the body content to the.
But wait, so we don't. So if we get a block from the network and the block doesn't match, I mean the body doesn't match, we just, my opinion, we just either drop the whole connection or drop that package. I don't think we ever even start to process such a block.
Yeah, but the question is, do you propagate it before processing?
Well, no, because we should in theory reject it even at the networking level because it's an invalid thing.
Yeah, then it would be fine. Then it will be fine. I think I'm pretty sure that the attacker was actually using a modified code to just generate the connections and send the blocks, because they were definitely coming from the get nodes, but they might have been modified.
Yeah, but Peter, it does make it into the bad block cache, though.
Oh, okay. I have to take a look.
Would a post-mortem on this be something that Nethermind would be able to do? Have something about it?
No, we can try to like copy the data from the Telegram channel where we're discussing it with Nethermind. Yeah, with Parity team. Yeah, I'll send a few questions, a few answers, I mean, like post-mortem, but like I cannot promise yet that it will be very quickly done on the like formal way. So like if we don't have to rush it now, but I think like the next week or two we can prepare.
Sounds fine to me.
Once again?
That sounds fine to me.
Okay, thanks.
Unless anyone else has thoughts.
Yeah, that sounds good. Anybody else have anything? Should we have the meeting in 2 weeks from now? We realize now that we're on the same weekly schedule as the ETH 2.0 calls, but I think someone mentioned there's not a ton of overlap. And also we've stayed on schedule and we think they got off schedule, so it might be on them to not have it the same week if they don't want it. Let's just have a meeting in 2 weeks then if no one has a strong opinion.
Agreed.
And I will be gone in 2 weeks on a trip, so Tim will be taking over that meeting. Thank you, Tim, who had to leave, I think, this meeting. But
Tim's going to be
anyways,
in Australia next week, so hopefully he'll be back in 2 weeks, but we can figure it out if he's not.
Yeah, we'll figure it out. He already told me he should be able to do it, so but there's other people I think who can if he can't. So that's it. Thanks, everybody. See you in 2 weeks.
Thank you.
Thank you.
Thank you. Bye.
Bye.
Cheers.
Thanks. Bye.
Thanks, Hudson. Bye-bye.